So I know I got cut off, but like I was saying, each of these domain values only has one y value. The y values can have multiple x values attached to it as long as the x's, the domain, only has one y. So remember, this one was not a function. Okay, so this one was not a function because 3 was paired with negative 2, 3 was paired with negative 1, and 3 was paired with positive 1. This one is a function because negative 4 is only paired with 2, negative 8 is only paired with 2, 4 is only paired with 1, and 5 is only paired with 1. So this is a function because, make sure you spell because right. And I gave you the reason down there. The domain x values each have only one range y values that are in relation to it. Though some x's share the same y value, each x only relates to one y. So there we go. So let's try our last example. This one is actually on a graph already, and it's not even just a line, it's an entire parallelogram, so you have a whole shape there. So we're going to go ahead and list our domain and range. So I want y'all to try to list your domain and range, but actually, I'm not going to have you list your domain and range because this one is very different. So let's think about this. This one is that type of graph that I told you was continuous. If we look here at my x values, my x's start at this point, and then since it's a line, it continues and continues, and every single x in between here and here have a value. So my x's go from this point all the way to that point continuously. So all of the other x's we had were discrete in that they were just individual x values. This one is continuous in that the x continues the entire time. So when we list the domain for this one, we need to include an inequality that lists all of the possible values of x. So what is the smallest possible value for x? Yes, the smallest possible value for x is negative 5. This point right here is at negative 5. Does it include negative 5? Yay! Yes, it does. Negative 5 is a point on there. So my domain is going to be any x, negative 5 is less than or equal to x. But then my x's continue this entire time. They're not individual points. It's the entire thing up until x is equal to what point? Yep, x is equal to 3. So my domain for this is going to be negative 5 less than or equal to x less than or equal to 3. Any x in between negative 5 and 3 is part of my domain. Even if it's 1.5 or 1.25 or negative 3.8293 or negative 1 and 1/3. All of those are included because the line is continuous. So take a second, pause the video, and make sure you have this written down, and take a second to really think about it also. So now that we have that listed, I want you to look at the y's. Are the y's also continuous? Is it a line that continues? It is. So I want you to try to do the range on your own, write that inequality, and then unpause the video after you write it to check if you're right. Okay, so when we look here, this is my highest y value and this is my lowest y value. So I know that y needs to go from positive 1 continuously down to negative 2. So my range is going to be negative 2. Ay, Dios mío, I accidentally wrote x. Negative 2 less than or equal to y less than or equal to positive 1. Any number in between negative 2 and positive 1 is part of my range. So now it's time to decide if this is a function or not. Well, let's look here. Do each of these x values have only one y value? So let's look. When x, for example, is negative 2. If x is negative 2, I have y here being positive 1, but I also have y here being negative 2. So nope, this is not a function, and there's multiple examples of that. I want you, though, to explain why in your own words. So the parallelogram is or is not a function because blank. Explain that in your own words. So your assignment to check your understanding is to go fill in the domain and range of the two relations on the front page, label them functions or not functions, and then explain the why